H2, we know that the general form for a quadratic function is f of x is equal to ax squared plus bx plus c, okay, where a, b, and c are real numbers. And we can rewrite this quadratic function in what is called standard form, which is equal to a times x minus h squared plus k. Where a, h, and k, right, are real numbers. And the vertex, right, we talked about this on Monday, the vertex of the parabola, right, for this quadratic function, its x coordinate has the value of h, and its y coordinate has the value of k. Okay. So we can go from ax squared plus bx plus c form to standard form. And there are two ways to do that. And the way we're going to learn first is by completing the square. And we did that in rewriting the equation of a circle from general form to standard form. Okay. So just remind ourselves what completing the square involves. All right, so we take a perfect trinomial, right, this is called a perfect trinomial. And it can be written as a perfect square. Right? When you factor that perfect trinomial, you get x plus 3 times x plus 3. Right? A perfect square. So we're going to take a quadratic function in ax squared plus bx plus c form, and with these first two terms, create a perfect trinomial that can be factored into a perfect square. That's what this is. X minus h squared is a perfect square. All right. So in example 3 here, right, we're going to do this with two different quadratic functions. So you might want to draw a line down the middle. Okay. To separate A from B. And so in A we have the quadratic function f of x is equal to x squared plus 2x plus 5, right? And you can see a is equal to 1, b is equal to 2, and c is equal to 5. So f of x, we got to complete the square, right, on those two terms, x squared plus 2x. So on the right-hand side, we're going to have to add a number and subtract that same number in order to complete the square here on x squared plus 2x. And then we have the plus 5. Whatever we add, we got to subtract, right? So that we're basically adding 0 to the right-hand side. It doesn't change the right-hand side. And so to complete the square on the variable x, if you remember correctly, you take the number in front of x, divide it by 2, and then square the result. Okay. That's what we did with the equation of a circle, right? Going from general form to standard form. Except we had to do it for both variable x and variable y. And so 2 divided by 2 is 1, and 1 squared is 1. So we're going to add 1 and subtract 1 from the right-hand side, right? Plus 1 minus 1 goes into the blanks. and then plus 5. So this guy here now is a perfect trinomial. And it factors into x plus 1 times x plus 1. We have f of x is equal to x plus 1 times x plus 1, and then minus 1 plus 5 is plus 4. So x plus 1 times itself, it's perfect square, right? So we went from a perfect trinomial to a perfect square. So this is the equation of this, or that's the quadratic, that's this quadratic function written in standard form, right? They're the same function, they have the same parabola. All right. So either looking at this one or this form of the quadratic function, we know that the graph of the quadrant is a parabola, but does the parabola open up or does it open down? It opens up because a is equal to 1, and 1 is greater than 0. So the parabola opens up. Because a is equal to 1, right, which is greater than 0. Okay. So that's the second thing. Find the vertex and sketch the graph of the given function. Okay. Well, h in this case, okay, remember you got to change the sign for h is x minus h. So you got to change the sign for this one, but you don't change the sign for this one. So h is equal to minus 1, and k is equal to 4, and the vertex is at the point hk. So in this case, the vertex is at the point minus 1 in the coordinate plane. So here's a crude sketch of the parabola. And it's very crude. So here's minus 1 on the x-axis. There's 1, 2, 3, 4 on the y-axis. So here's where the vertex is. And it opens up. Okay. And we know from Monday's lecture, the y-intercept, the graph of this parabola is equal to y equals 5, right? Because you put in 0, 1 for x. Both two terms are equal to 0. So it's going to cross the y-axis at y equals 5. So very crudely, that's what the graph looks like. Okay. Any questions on that? Yes, ma'am.
Sorry, can you go over how you got h is negative 1 again?
Okay, so the standard form for the quadratic function is a times x minus h squared plus k, right? And for this problem, we have a is 1, and we have x plus 1 squared plus 4, right? So x minus h is equal to x plus 1. When you subtract x from both sides, you end up with minus h is equal to plus 1. And then when you divide both sides by negative 1, you get h is equal to negative 1.
Okay.
So you got to change the sign of the number.
Okay.
So, yeah. All right. Any questions? Now, this is the long way. There's a shorter way of writing this in standard form. Okay? But the reason we're doing this is because on the comprehensive final exam at the end of the semester, the math department will often insist that you do this by completing the square. Remember Monday, we pointed out that the x-coordinate h for the vertex is equal to negative b over 2a. In this case, b is equal to 2, so negative b is negative 2, and a is equal to 1, so we have minus 2 over 2, which is negative 1, which we pointed out over here. K is equal to the quadratic function evaluated at h, which is h is negative 1 in this case. And so when you plug in negative 1 into x here on the right-hand side, you get minus 1 squared plus 2 times minus 1 plus 5. And when you do PEMDAS, right, you have 1 minus 2 plus 5. So you end up with k is equal to 4. That's what we have here. So this, for me, is a much faster way of going from ax squared plus bx plus c form to standard form, okay? Much faster going from this form, instead ax squared plus bx plus c form to standard form. But you have to be able to do it by completing the square on final exam. How you do it on exam 2, I don't care. Whatever you prefer. Complete square, right? Or you can do this. Okay? Doesn't matter to me. Okay? This is faster for me. Okay? But I want to point out, right, there are two approaches to going from ax squared plus bx plus c form to standard form. Okay? All right, any questions? All right, now let's take a look at one that's a little more complicated. We have f of x is equal to 2 times x squared plus 12x plus 15. And so you can see a is equal to 2, b is equal to 12, c is equal to 15. Now, for me, it would be faster to rewrite this in standard form, doing what I just did, right? H is equal to negative b over 2a, so forth. But we got to do it by completing the square as well. Okay? So, we got to create a perfect trinomial, right? With those two terms. But one issue we have is the number in front of the x squared is 2. We can't just take this 12 and divide it by 2 and then square it because of the 2 in front of x squared. You got to have a 1 in front of x squared before you do that. So we're going to factor out 2 from these two terms. and we have 2 times x squared plus 6x plus 15. Okay? So from the 2x squared plus 12x, I factored out a 2. Now, inside the parentheses, I'm going to add and subtract the number. X squared plus 6x plus minus, and then let's slow down. Right, so inside parentheses here, I'm going to add a number and subtract a number. Right, that's what the blanks are for, right? Add a number and subtract the same number. So now I can create a perfect trinomial with x squared plus 6x by taking the number in front of the x, 6, divide it by 2, and square the result. 6 divided by 2 is 3, and 3 squared is 9. So inside parentheses here, I add 9 and I subtract 9. Okay. Then we got the plus 15. Right. 9 minus 9 is 0. So we're just adding 0 inside the parentheses. Well, this x squared plus 6x plus 9 is a perfect trinomial. It factors into a perfect square. So we have f of x is equal to 2 times, now I use brackets, x squared plus 6x plus 9 factors into x plus 3 times x plus 3. And then we have the minus 9. And then outside the brackets, we have plus 15 all by itself. Well, x plus 3 times x plus 3 is x plus 3 squared. Right? So that's our perfect square. Now to get it in standard form, I got to distribute the 2 inside the brackets, right? I have 2 terms inside the brackets, right? So I got to multiply x plus 3 squared by 2, and I got to multiply the minus 9 by 2. And I distribute the 2 inside the brackets. So f of x is equal to 2 times x plus 3 squared minus 2 times 9, which is 18. So f of x is 2 times x plus 3 squared minus 18 plus 15, and minus 18 plus 15 is minus 3. So this is our quadratic function here, written in standard form. You notice the value of a is the same. If your value of a changes, you did something wrong. Right? A is equal to 2 over here. You better equal 2 over here as well. All right. Does the parabola open up or open down? Up, right? A is equal to 2, right? Which is greater than 0, right? So the parabola opens up. Now the vertex is at the point HK. So what is H equal in this case? You gotta take this number, right? Inside the perfect square, and you gotta change the sign, right? So H is equal to -3. What's K equal to? Yeah, it's -3. You don't change the sign to K. So the vertex is at the point HK, in the coordinate plane, which is the point -3, -3. So now we can sketch the graph of the given function. So the vertex is at -3, -3. So, you know, -3, -3 is in the third quadrant. So here's -1, -2, -3 on the x-axis, -1, -2, -3 on the y-axis. Probably not drawing scale. But here's the vertex. And then the y-intercept's at y equals 15, which is way up here somewhere. Okay. So I don't want to say where it's going to cross the x-axis, but it's going to go up. So that's a crude sketch, okay? I hope you got what's inside. Okay. All right. So any questions on that? So again, right? This is an exam question. This is an exam 2 question. I'm not going to tell you what method to use to go from general form to standard form, but comprehensive final exam you may have to do complete square. So again, H is equal to -b over 2a. Negative b in this case is -12, and 2 times a is 2 times 2, and -12, right? 2 times 2 is 4, and -12 over 4 is equal to -3. This is what we got right here. Okay? And K is equal to f of h, which is f of -3. I'm going to put in -3 in for x here. I have 2 times -3 squared plus 12 times -3 plus 15. A into PEMDAS, -3 squared is 9. 12 times -3 is -36 plus 15. 18 is hitting 33 -3. K is equal to -3. Same as what we got over there. Okay. You with me? So if you know, I think this is a whole lot faster, right? To go from general form to standard form. But on the comprehensive final exam, right, they have required in the past that you solve this problem by completing square. Okay. We got to do both methods. Okay. On the website homework, They don't know what method you're using. They only know whether you get the right answer. Alright, so any questions on that? Okay. Alright, so you flip over to the top of page 3. Talk about the quadratic formula. Now, so here is quadratic function in ax squared plus bx plus c form. Find the x-intercepts in the graph of this quadratic function, right? We set y equal to 0 and solve for x, right? And remember, f of x and y, right? Function values and y values are the same thing, right? So you can write this as y equals ax squared bx plus c. So when you set y equal to 0 and solve for x, right? You end up setting the right-hand side ax squared plus bx plus c equal to 0. Okay. Well, to find the values of x that make the left-hand side equal to 0, you can use what's called the quadratic formula. Okay. So that quadratic formula that you probably saw many times in high school is derived by completing the square on the left-hand side. So, at the top where it says quadratic formula, you know the values of x that make the left-hand side equal to 0 are from the formula x is equal to negative b plus or minus the square root b squared minus 4 times a times c, all divided by 2a. You plug in for a, b, and c, and you get the values of x that make the left-hand side equal to 0. Okay. Now, this under the square root, b squared minus 4 times a times c, is called the discriminant. And its numerical value tells you how many x-intercepts there are. Or either be 2, 1, or 0. Okay. So down below here, we're going to cover the 3 scenarios, okay, that can occur. So in scenario number 1, the discriminant b squared minus 4 times a times c can be a positive real number. And if this discriminant is a positive real number, okay, greater than 0, then there will be, right from this equation up here, from this formula, there'll be 2 distinct real solutions right? The 2 values of x will be 2 real numbers, and that means that there are 2 intercepts, 2 x-intercepts in the graph under that scenario. If b squared minus 4ac is a positive real number, then there'll be 2 x-intercepts. Okay? So I'm going to draw 2 parabolas on one part plane, right? So you could have a situation like this. Parabola opens up, crosses its 2 locations, or you can have a situation where the parabola opens down and it crosses in two locations. Okay? So b squared minus 4ac is greater than 0. You'll have two x-intercepts, regardless of whether it opens up or opens down. Okay? If the discriminant b squared minus 4 times a times c is exactly equal to 0, okay? Then there's only one real solution. From our formula, right? There's only one value of x from our formula, okay? One real number for the value of x. And so there's only one x-intercept. When that happens, and so the parabola just touches the x-axis in that case. So over here, right, the vertex of the parabola will be on the x-axis. If it opens up, the vertex, right, will just touch the x-axis. And if it opens down, the vertex will just touch the x-axis. And so there'll be just one x-intercept. Okay? If b squared minus 4 times a times c is exactly equal to 0, right, there'll be exactly one x-intercept. Okay, and there'll be at the vertex. Now the third scenario, and I'm sure you guys probably did this in high school, where you had the number I, when you solved the quadratic formula, you had the number I, you took the square root of a negative number, right? You had I. So if the discriminant b squared minus 4 times a times c is less than 0, which means it's negative, now you're taking the square root of a negative number, negative value, and square root of a negative value is imaginary, right? It's not a real number. So when that happens, you see there are no real solutions. All right, by real solutions we mean there are no solutions that's a real number. So there are no real solutions. And so the parabola in that case is entirely above or below the x-axis. So in that scenario, right, when you do the quadratic formula and you got the number I involved, the parabola is either entirely above the x-axis or entirely below the x-axis. There's no x-intercept. It never crosses the x-axis. It touches it. Okay? All right. So any questions on that, ladies and gentlemen? So let's do a couple of problems using the quadratic formula. So again, you might want to draw a line down the middle of the page. Okay? Use the quadratic formula to solve the equation. So we have x squared minus 8x plus 13 is equal to 0. We're finding out there one x-intercept, two x-intercepts, or no x-intercepts. So a is equal to 1 in this case, b is equal to negative 8, and c is equal to 13. So x is equal to, right, negative b plus or minus the square root b squared minus 4ac over 2a. Well, negative b in this case is the negative of negative 8. B squared is minus 8 squared. We have minus 4 times a, which is 1, and then times c, which is 13. All divided by 2 times a, which is 2 times 1. Now again, under the radical, you got to follow the order of operations, right? Exponentiation, then multiplication, then the subtraction, right? So x is equal to negative of negative 8 is plus 8. Under the square root, minus 8 squared is 64. And then do the multiplication. 4 times 1 times 13 is 52. So we have 64 minus 52 under the radical. All that divided by 2. Well, 64 minus 52 is equal to 12. And now you got to reduce the radical to lowest terms, right? So square root of 12 can be written as square root of 4 times 3. And square root of 4 times 3 is equal to the square root of 4 times the square root of 3, right, by the rules of radicals. Square root of 4 is 2. Right, so square root of 12 reduces to 2 times the square root of 3 over 2. Now, fraction bars are like division symbols. So we got to divide each of these terms by 2. So we have 8 over 2 plus or minus 2 times the square root of 3 over 2. Eight divided by 2 is 4. And then in the second fraction, the 2's cancel. And we're left with plus or minus 3, square root of 3. So there are 2 solutions, 2 real solutions. So there are 2 x-intercepts. The first one is that x equals 4 plus the square root of 3. And the second one is that 4 minus the square root of 3. Right? Use the plus sign and the minus sign separately. You don't have to write them both out, right? You can stop right here. But I wanted to emphasize, right, there are 2 solutions. All right. So we'll finish this up first thing tomorrow. But I have 2.5, and I'm going to hand it out now, so I don't have to carry it around. But you guys should be right? You got enough to complete the homework. We're almost completed, except for maybe 3 problems. Okay, so I'll see you guys tomorrow. Good night.